So the question has been asked in NEET 2017. It says that consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second. Take G constant with a value of 10 meter per second square. The work done by the gravitational force and the resistive air force is. So we're given with a drop of rain, and this particular drop of rain falls from a height of 1 kilometer to the ground. Also, the mass of this raindrop is also given, that is 1 grams, and it falls on the ground with a speed of 50 meter per second square, that is its final velocity is given to us. Now we know that initially the raindrop is just released, so its initial velocity is going to be 0 and its final velocity is going to be 50 meter per second. Now, the first thing that we're going to find out is the work done by the gravitational force, which is a part of the question. Now, the work done by the gravitational force, we know it's equal to mg, that is the gravitational force itself, multiplied by the height through which the object falls or rises. If it falls, then it's moving in the direction of the gravitational force, so it's going to be positive, and if it rises, it's going to be against the direction of the gravitational force, hence the work done by gravity in that case is going to be negative. Now, if we look at the work done by gravity in this case, it's going to be mass into acceleration due to gravity into height. Now, the mass that we're given with is 1 gram. So we know we have to convert it into an SI unit of kilograms. That's going to be 1 into 10 raised to the power minus 3 multiplied by the acceleration due to gravity that we take is 10 meter per second square, and the height through which it falls. Now again, we're given the height in kilometers. We have to convert it into SI unit of meters. That's going to be 10 raised to the power 3 meters. 1 kilometer equals 1000 meters. Now, we're going to write the work done by gravity. This 10 raised to the power minus 3 is going to cancel out the 10 raised to the power 3, and we're going to have 10 joules. And this is going to be positive because the raindrop is falling towards the direction in which the gravitational force is applying its force, in which the gravitational force is doing its work. The next thing that we're going to do is that we're going to find the resistive force of air. Now, to find the resistive force of air, we're going to use the work energy theorem, which states that the work done by all of the forces inside a system, whether they be conservative like gravity or non-conservative like air resistance, that's going to be equal to the change in kinetic and energy, that is half mv square minus u square. Now, we already found the work done by gravity, that is 10 joules. We have to find that the work that is done by the air resistance or the resistive force of air, and that's going to be equal to the change in kinetic energy. Half, we know what m is, it's 10 raised to the power minus 3 kilograms because mass is given to us in grams, and we know that our initial velocity is 0. Because the raindrop is just released from the height, so its initial velocity is 0, and its final velocity is given to us in the question 50 meter per second. So 50 into 50 because it's v square. Now, 2 1s are 2, 2 25s are 50. 25 into 50 is going to be 1250 multiplied by 10 to the power minus 3 minus 10 is going to give us the work done by the resistive force of air. So this is going to be 1.25 because we can generally express it as 1250 divided by 1000 minus 10, and we're going to get minus 8.75 joules. That is the resistive force of air and the work done by it on this particular raindrop. That is minus 8.75 joules.